Hi and welcome everyone to our presentation on next generation CPQ tooling for sales enablement. My name is Sebastian Schmidt and I'm CEO at MetaFacts. So today I want to talk to you about how knowledge graphs can be utilized to provide sales enablement, specifically on topics around configuration, pricing, and quoting. Now, the idea is that is going to be kind of the center of our discussion, but it's going to touch on a lot of additional disciplines around that. And we're also going to have a demo where you get to see how exactly this works. Before we start into that, just a few words on MetaFacts. So we are around since 2014, working with our customers on unlocking the value of their data utilizing knowledge graphs. We are working in a number of different verticals and completely different use cases, where there's always the same challenge that data is available in some way. It might be just in the form of relational databases, or it might be on files and documents. But very often there is a lot of essential knowledge that is not in that data, or that is not easy to extract from that data. Information that is just in the heads of a domain expert, where they know exactly how to interpret the data, how to use the data, or where it hasn't even been digitally captured in any way so far. So what we do is we help you model that knowledge, bring that together with the data you have, make sense of that data, and support your use cases with that. And the one we're going to look at today is around CPQ and PLM. We are headquartered in Waldorf, Germany, have an international team across multiple locations, and we are a software vendor. So the way we enable our customers is through a software product called MetaFactory, which is our knowledge democratization platform. So again, the idea of bringing that knowledge into an IT system, making it accessible to everyone, and through that, democratizing that knowledge, allowing everyone to use it in their daily work. Now, what is CPQ actually? So it's a process of configuration, quoting, pricing done by sales, and it starts with a request from a customer, which would then be assigned a configuration and a quote with a pricing for that configuration, which then results in an order, which goes into a factory for production, and then to a service engineer for maintenance and service. Now, we are supporting actually throughout that whole kind of a life cycle, supporting with the CPQ solution we see today, supporting on the product lifecycle management, with matching products and configurations to capabilities and requirements, providing configuration rules and pricing rules, as well as business rules that define what exactly is offered to a customer, but also in taking that into the factory and making that same knowledge and information available for production, and also tying that back into for example, the PLM process again. And then also utilizing that for maintenance and service, combining it with relevant service contracts, combining it with maintenance information. And we're going to talk about the different use cases that derive from that and the additional capabilities we unlock with this approach. Now, why does this matter, especially around the CPQ topic? So our goal is it's very simple. It's a valid, correct, and optimal configuration. What do I mean with that? So first of all, we have to ensure that the product can actually be produced and is technically feasible. So it needs to be valid. And the challenge is that we have a lot of different data models and software systems for product definition, configuration, production. So it's not easy to ensure that they actually are all built on the same logic and they're all up to date. And what we saw is that additionally, this heavily relies on domain experts. So very often the software systems are actually not up to date on the latest status, or there are relevant aspects that are not captured because the proprietary system was not able to model that specific information. Which means whatever kind of configuration you might get out of your configuration system might actually not be a valid configuration. And a domain expert has to review that, have to provide feedback, and it has to be reconfigured. Meaning you lose time, you might lose trust with your customer, and all kinds of issues in that process, plus a lot of expertise that needs to be made available by ensuring people get trained on that, which means when you bring in new people for configurations, there's a long ramp up period of training them and ensuring they have all the relevant knowledge required in the process. The next thing is we have to match it to the customer requirements. It has to be correct to their needs. So again, here, relevant information is often hidden in text documents in the way that the customer specifies those requirements. Data about capabilities is hidden in proprietary systems, in technical documentation. It's really hard to extract, and it's hard to reuse and hard to map those things. And then it needs to be optimized. It needs to be optimal along a number of relevant factors like sustainability, for which, in our experience, there are often no reliable or maybe not even any models available on how a certain configuration, a certain component would actually affect sustainability throughout the whole process. Fast and efficient production. So for that, you would need to have production insights. You would need to understand all active configurations, quotes, and orders, and the different machine skills and machine configurations in place to see what could be quickly produced without having to change anything. How could you best combine orders in production and so on. Reduced variance plays in that same direction. So you need to have insights into past configurations. You need to have learnings from existing configurations to understand where you might be able to reduce variance, or where variance is actually a major issue compared to where it might not be. And then you want to have a profitable and competitive pricing. It was one of the most surprising topics for me, where pricing in especially highly complex products is considered an art. So experienced experts kind of guesstimate a price because relevant and reliable rules are not existing, which obviously poses a huge risk. So how do we approach that? With our software platform, we provide two key capabilities. One is a way to model all of that knowledge, so really capture expert knowledge in a semantic knowledge model, in an ontology, without requiring those business users or domain experts to understand the underlying semantic web standards. And on the other side, we then produce an end-user interface from that, where users can capture information, where they can capture configurations, where they can do a configuration in order. And all of that is driven from those models. So as you adjust models, as the logic of your process changes, as additional concepts are introduced, the end users will directly see those changes and can immediately interact with them. Which means overall you have a very low maintenance overhead, and you have a very high flexibility in the tooling you're creating here. And there are some additional things which are different about the solution we are proposing here. So very important again to point out is we are building on top of open standards. So everything you're creating is utilizing the W3C semantic web standards, which means there's no proprietary component in that. Your models, your configurations can be easily imported and exported. there is really maximum flexibility in how you configure that. And everything you create, all of those models, result in a human and machine understandable artifact. It is highly adjustable to your own needs, as I already said, but the interesting part is that a common implementation is just 4 to 6 weeks to get this in place. So it really is quick to implement, easy to implement, and then easy to extend and maintain. And we also allow you, and we're not going to be able to cover that in the demo, but please reach out if that's interesting to you. We can also layer our model on top of ISO or IEC standards so that you achieve interoperability of what you're creating with suppliers and partners. So with that, let's jump into the demo. So this is our knowledge graph-based product configurator based on MetaFactory. The complete interface is derived directly from the underlying semantic models, the ontologies. So we're going to look at those first. We currently have 3 ontologies loaded and defined, which is a configuration ontology holding core configuration information required to understand a product, its components, features, and their specific values. Configuration rule ontology that sits on top of that, as well as an order ontology. So let's look at them one by one. The configuration ontology, as I said, has information about the product model, which consists of several components. The components have positions in the bill of material, then specifically for each feature, and then the features have values assigned to them. This is obviously just a starting model, and while going through the demo, we will also further expand this model. We can then layer on top and as a modular component an order ontology, again very simplified here. So we have a product configuration for a customer. The product configuration instantiates a specific product model, and it contains a number of value selections, and those value selections consist of bill of material positions together with values. So we can see that the product model, position, and value come from our existing configuration ontology. You can also expand here and see how it connects to the other parts of that model. So before we look at the rules, let's look at what we can do with that. So our product manager has already defined the configuration options. So we can see the current product model is a transportation vehicle. The vehicle has a number of components. Currently, those are a wheel, drivetrain, and engine. And we have according definitions for bill of material positions. And then into those, we tie the different features. So, for example, a wheel diameter on position 10 or the rim color on position 11. And then for each of those features, we have values. So we can, for example, look here specifically at the engine types, where we see we have electrical and combustion engines. So we can now use those configurations, and we can create our own instance of a transportation vehicle for a customer. So you can see we already have a family car that has been configured here. So let's do another family car. And then for that family car, we can select the drivetrain. So we want to have a two-wheel drive. We can look at the wheels. We'll take 14-inch wheels. We see the rim color is already limited, so there seem to be already a number of rules in place, and we can also look at them later. And then we select our engine type, and we're going to choose an electrical engine. So Now we can check. We see seems to be a valid configuration, and it says we proceeded successfully. So we now have two complete configurations in here. So as a next step, let's extend our model and see how the complete user interface automatically reacts to that. So the first thing we want to include is units. So currently those values do not have units. We saw the wheels, for example, with 14-inch. So it would be actually good to have the concept of a unit. This would likely be something that we utilize a public vocabulary for that defines the different options for units. In our case here, we're just going to later manually define some units. So a value has a unit, and then obviously a unit is assigned to a specific feature. That's the unit for that feature. We can now save that. We will also have versioning, so people could also suggest an extension and then would go through an approval workflow. We're kind of shortcutting all of that for the demo here. So with that extended model, I also want to quickly look at the configuration rule ontology, because we're also going to do some modifications there in a second to the actual rules that are configured. So we see how this ties into the other two ontologies, so our configuration ontology as well as our order ontology. So first of all, we have intercomponent rules that define if we have a certain value on a certain component, then we conclude the value for another component from that. And we have bidirectional rules where we can define a number of dependency references, and if any of those, so any of those combinations of component and value show up, then we conclude from that all of the other dependency references in that rule have to apply as well. Again, there could be a number of other rules. There could be pricing rules and other extensions we could do to that, but we wanted to keep it rather simple for this demo. So now we're going back here and we open the instance manager because we want to do some extensions. We're going to start on the configuration, and we can now see that we also have units here. So the user interface directly reacted to our extension of the model, and we can also go in here for the values, and for the wheel diameter we can now also select units. So let's create a unit for that. So the unit is for wheel diameter. Oh, and I see I didn't define that our unit needs to have a name. So let's quickly take care of that. So we look again at our unit, and it obviously needs to have an attribute. We call that label. We're already using that for the other options. It's a string, and it needs to be exactly 1. So we're going to apply that here. We're going to save it. And now we go back. Configuration, and we create our new unit. So now we can say that we have the unit inch, and that's a unit for wheel diameter. We save that. And now for our values here, we can now say we want to use the inch unit. And in the same way here. And here. And we made unit an optional parameter by not specifying a minimum, maximum, so we can just leave the arrows the way they are. So another thing we want to do is we want to introduce an additional component. So currently we have the wheel, drivetrain, and engine. It would be good to also specify the body. And that's again for the transportation vehicle. Now we need to also create a position for that. So we're going to give it a new number, and that's for the body. And then to that position, we would assign a feature. So we're going to create a new feature, and it is the body style, which we assign to 50 body. And then we need to add values to that. So we create a new value, which is station wagon. We don't need a unit for that, and we assign it to body style. Let's create a few more. So SUV for body style, and let's create one more, which is a sedan body style. Save. So with that, we have further expanded this, and we can now also look at the configuration rules. So we specifically will look at intercomponent rules here. So we already see we have configurations like a four-wheel drive requires a combustion engine. If we have two-wheel drive, then the rims need to be black. So we can create a new rule, and we want to say if the body selection is for a SUV, then we want to have a drivetrain which is four-wheel drive. So SUV requires four-wheel drive, and we save that. So with those extensions, we can go back, and the first thing we see is that our configurations have become incomplete because we have now additional rules and additional parameters that have not been captured here. So we could actually go in and adjust those, but we're just going to create a new one. And we want to create a heavy truck. So the body style now shows up here as an option. We can see that the drivetrain type shows up here. And we can now, for example, go ahead and select that this is supposed to be an SUV. We see now there's only four-wheel drive available. We saw earlier four-wheel drive also affects the wheel diameter. Then we select the engine type, so we see there is only the combustion engine because this is a four-wheel drive. We select our rim color, and we see now all of our configurations are valid. We can see a quick summary. and we can place this order. Now we can go back and see we have a complete configuration in here. So I want to talk about some additional aspects of this. Obviously, what we're proposing is not a system that's going to stand on its own. It's going to be embedded into an ecosystem of existing tools. There are PLM, PDM, ERP, CRM, and other already in place, very likely. What we're proposing is to interface with them, to create a new authoritative source for business configuration and pricing rules, a new authoritative source for product definitions and capabilities. That is interlinking the data from all of these other systems. So interlinking with the relevant IDs and master data that is present there, and capturing the relations between them, the logic, the rules, the connections. Because that is what, in our experience, those other systems are not really capable of doing, and especially not doing in that flexibility and speed of innovation. And then all of the maintenance for that would happen inside of MetaFactory, as well as the sharing of that and exporting that, which could be between those tools, but could also be, for example, external with suppliers or partners. There are some additional benefits beyond the obvious one, where we can utilize that to support completely new use cases. So for example, we can have pricing drive the configuration. So we can use price to support and enforce easier, faster, better, cheaper manufacturing options by having that understanding of what would be currently easy to manufacture. Where do we have material available? Where there's maybe a very high stock in the warehouse? Where are the machines in the factory already configured to produce exactly that variant? We can control through price what we would like customers to provide in their configuration. Through that, we can also reduce variance. So if there are certain variations that we would actually not like to provide, we can utilize price as a measure to see if we can direct customers towards something else. Configurations can drive new features and products. So we will see what is often requested together. We're collecting additional information on where each part was utilized. Information that, for example, also can help us understand the servicing and maintenance process better of where parts have been utilized. We can see which feature requests can't result in a possible configuration today. So we see what customers are actually requesting and we are not able to deliver on. And we see which specific of our restrictions are holding that back, so we can see if that is something we can lift and where we can maybe provide a new product. And then configuration can drive sales. So we can highlight what else could be interesting for the customer. We can upsell to additional features. We can highlight common additions that others had in their configuration that the customer might have missed out on. And as I mentioned already, maintenance and service intelligence. So by having all of the information, we can have predictive maintenance. We unlock predictive maintenance options by understanding, where each individual part exactly has been combined with other parts and learning from existing service incidents where that might happen next again. So with that, I'm going to conclude my presentation and open it up for question and answers. You can ask right away here, or you can also reach out to info@metafacts.com. Thanks a lot.